Nuke the place from orbit, it's the only way to be sure. Hi there, I am Mike Levin on Monday, March 8th, 2021. And when last we left off, I was showing you how to use JupyterLab to simulate command line tools so that you can use it in a scheduling system with variable input parameters. Very useful. Develop your command line here, test it over in a true command line, and deploy it into the cloud or whatever. No web servers even needed. It's a different method of working. And I was showing you how I generally collect my data. And for the sake of convenience and deferring lots of future work, we work in Nosql mode. And what that does is it allows us to use fetch parameters. This is stuff that's used on the request. And on the response, a big object comes back from out there, in the wild, probably on the cloud somewhere. And it comes back from the request. The request goes out to the cloud. The cloud comes back with a binary large object response. It could be anything. It could be a JSON object. It could be a response object and a whole bunch of stuff. But what it's definitely not is very carefully planned out rows and columns. This is generally unstructured. I can't really call it unstructured, but it is not tabular data. It is not rows and columns. And the thing there is you make the next request, you get the next blob, you make the next request, and so on down. And the advantage is your search speed. It's a hash search. I think they use btrieve in SQLite, but when you look at this later, you can process this whole thing much faster than one would think given a bundle of keys and values. And this, by the way, when we back end it with SQLite, which is what we're doing, we're not really, using the rows and columns features of it. We're using the dict feature of it, but we can use that same exact SQLite engine over here with a different output file. So we're using SQLite here with Sqlite Dict, which is a third-party package you can get to achieve the same NoSQL type world inside a tool that's meant for the very row and column. We'll use magenta because it's the magical transition color, because what we're doing in almost every case is we're taking the data from out of here, making some sort of loop that spins through it, and then we do a data transform. This middle world between the world is really the world of transforms. And there's a ton of way to do data transforms. But generally it's some sort of query against the left. And then it's some sort of composition process into rows and columns to the right. And, there's a lot of, I'm going to use probably, list comprehension. So mapping the JSON through list comprehension into standard Python objects that I turn into potentially data frames, or I could just insert it a row at a time with raw SQL. There's a lot of choices there. But I got up to that point and I said, no, that's chasing the rabbit. We'll deal with those transforms later. And this is where I went through that whole thought process. You remember I deferred Dask. Similarly, I'm deferring this wonderful thing 0MQ that I'd like to have in my first pass tools that I grab on every project. Same with Docker. Same with fixing a virtual env mistake I made, showing you where venv is the thing built in. This poetry system. So all this stuff I'd like to show you is just too much grabbing at once too early. And I get back to the fact that where I left off was a perfect transition to some more fundamental things in the operating system and in the Python built-ins. So there's OS stuff that's always there you can rely on. And then there's the Python built-ins before you even, built-in is how it's referred to, before you even import libraries. And what we're about to do with pickling really touches on one of the built-ins that's not given a lot of attention. So if we type built-in with the double underscore, you have to just be told this. This is similar in nature to the rants I was going on about logging and argparse. Some things in Python you just got to be indoctrinated to. So welcome to the indoctrination of the built-ins, which, like anything else, you can look at with a dir command and see what's inside of there. Now talk about standards and conventions. You've got your dunders, which are really easy to identify here. These are generally not intended for direct interaction. You've got your all lowercase stuff at the end of the list. These are public API things. You're supposed to be able to use these, and you'll recognize these as the built-ins of Python. Maybe you won't recognize them. Did you know you could get the absolute value of things? Did you know you could see whether every item in a list is true, whether all items in a list are true, whether any are, show an item as ASCII, show it as binary, different things you would do for different, what I guess Guido van Rossum believes are the most common use cases. Now there's this odd one here because open is a file system operation generally. Opening things has so much complexity to it that it's quite surprising you find it as part of the built-ins. And the pattern I'm about to show you here that goes back to my notes from Saturday, a video I was intended to make Saturday, shows you that you may recognize the context handler when you have with and as. It's like, oh, that's the context handler. There's an implied opening and closing of things involved. Well, it's not so much implied here as it is explicit. That's the built-in Python operator called open. What you're seeing here under the built-ins is the same thing way up here. And I'll address that in a second. There's a lot of built-ins that you're not going to need to do stuff with. And there's really only a few here that you do. And I went researching this. In fact, here's our list of built-ins. There's not very many of them. There's a common one a lot of people will recognize. Here's our open command. We drop down to open. And then we see another one of the problems that generally plagues Python. You can see these are the official docs, the docs at python.org. Here's open under the page that documents the built-in functions. And no really good example saying here's how you use it. Here's a piece of Python code. And when they do get to it, they use the opener parameter, which is such an edge case, and they're teaching people how to use things for, you don't need the operating system opener as a separate defined object. Oh my God, let me stop rambling and just show you what I mean. So we've established that open is a built-in, so you should be able to just type open and at least something happens. It tells you it's a function. Okay, when things are functions, you can put parentheses in and it tries to call it. It's not going to work because there's a missing required argument. Let's find out a little bit more about the open function. And this is the kind of stuff you should be doing with Python to just get a feel for what's in the system. Again, there's your dunders. So where's your public methods? File. Should be something called file there. So if dir lets you down, you can do help. And it gives you your built-in documentation, file, and the mode. Okay, so now things start to make sense. You got mode R for read, and we can look back here and you can see that there is read, write, open for exclusive creation. So there's some special things. Append is pretty common. Binary mode, and these work together so you can see if you want something to be in binary. Well, maybe you can't see, but from using this, if you want it in binary and write mode, it would be WB. Okay. So we're going to want our args to end up on the file system. Sounds straightforward enough, right? We know we're going to be using something having to do with the open function. which can read and write, so maybe we just use that. So open for the file. Well, we're opening a file for writing, so maybe we put the file name here, foo.txt, and we look at our API again. The order in which parameters come in and the way you feed stuff is your API. Open file, buffering. So there's really nothing for like a value you're going to be inserting in there. That's pretty odd. So even if you open a file for, say, reading, not much harm because of the closing that needs to be done is already done. So it just kind of happened. It's just kind of floating there in memory. And there's even some ambiguities. There might be memory things that don't clear up until we restart the kernel, because this is an open without a close. Now you can immediately give it its context with open as handle. Okay, and now we don't really even need to do anything. We can just pass in there. But now that's much more formal and explicit. There's a few things. First, there's a way to access data that we might be handling because we have a handle to it. The file is probably made there. Let's take a look inside that directory. We are currently working on the SEO one, SEO-ML. And there's my foo. I made a foo text. I wish I was showing that. It would have been a nice before and after. So now we've got a place to put things, but I'm just reading from it. So let me try and write into it. W. Now write as a text file, because this looks like text, right? So args is existing in memory right now. How would we put a text file named args onto the drive there? Well, let me look at our example, because sometimes you need to just be told these things. They're doing it with pickle.dumps. They're also doing it in binary format. I am probably going to not do that. I should be able to write a line into this using the file handler. So we have something called handle, and that has things that should be able to be accessible with hitting the tab. Now, the much maligned Jupyter Notebook and Labs have all the same, this stuff, pop-up stuff. I don't really use it much. It's built into VSC, and people go, oh, VSC is great because of this. But, sometimes when you want to learn stuff, it's good. But you want to get it into your fingers. You want to get it into your habits. So you can see there's read, readable, read line. We were interested in the write stuff. There's writable, write, and write lines. So we'll just do write because we don't have multiple lines here. Args. Oops, args. Not a dict. Okay, well, it doesn't want that data format. So we'll try writing a string representation of an arg in there. Bam, it's written. So if we were to click on this, we've just interacted with a file system. We have a file named foo that has our arguments there. See, isn't that great? I can open a terminal over here. I can cd into GitHub, SEO-ML, ls, vim foo. And there's that same file. So confirmation that the value I was sitting on top of here, where I explicitly defined it, I can drop it onto the hard drive with such a simple command. There's not even really any pickling going on. And it looks exactly like what the value was set as. Now the problem is I would have to read it in and parse it. I would have to figure out what it is. I'd have to make file equals file name here. It's a pure object in memory. It's a real actual Python object in memory here. Why can't I get it back as an actual, Python object in memory? Why does it have to be like a string representation of that object? Well, it doesn't. That's just me demonstrating this to you without Pickle before we put Pickle into the picture. Now pickle works without open, and open works without pickle. Pickle dump. Now there's pickle dump and there's pickle dumps. I'm not even going to copy it so I can demonstrate this to you. Whereas everything here was coming from the standard library, meaning no import was required, pickles do not. So you have to import the pickle. I-M-P-I-C-K-L-E, import pickle, import pickle. Okay, import pickle, right? So it's in memory. Now I can pickle dot load and dumps. If I dump dump it, I will be dumping whatever I put in here as required argument. Dump, missing required argument. Oh, handle. It needs a handle. It needs to put it somewhere. That's very interesting. Let me try dumping it as a string. There you go. This is what I'm trying to demonstrate. So pickle has dump and dumps and load and loads. Now you would think it has something to do with singular versus plural, but I'm telling you it doesn't. If you want to manipulate things on the file system directly, then you use dump and load. If you want to manipulate things in strings in memory, then you use the S. That's why dumps will show you the binary representation of this object here and keeps it in memory as a string to manipulate in your local Python environment without going out to the file system. This goes out to the file system. That's why we're not going to handle.write anything. Let's edit that bad boy out. Instead, we are going to see this text. It can't be text. It's got to be binary. I'm correcting myself ahead of time. And instead of writing to foo.text, it implies text, I'm going to be writing to args.pkl. That implies a pickle of my arguments. And instead of handle.write and avoiding stuff that has to be imported and using only the standard library, which is always a good idea, fewer dependencies, I will instead use pickle dot dumps, because we're putting data somewhere, but we're not putting it there as a string. We're putting it there as a binary object onto the file system. What are we putting? We're putting args. Where are we putting it? Into the file handle that we're sitting on top of. Now here's a before and after. You didn't get to see the foo appear, but you do get to see args.pickle appear. And if we were to go into it, can't even load it, but I'm sure I can load it here. And again, it just looks like, you know, binary garbage. You can maybe recognize a few things in there from the original object. And the string representation of the original object, that is the original object in binary. We're used to looking at the original object as a string, but now it is archived onto the hard drive. Let's make this easier to look at. Whoa. Let's see if I undo that. Undo cell operation. Shift Z. Z. I was too quick on the delete. So this is just working in Jupyter. You'll get to know it. My imports, I'm going to start to group all my imports together. This pickle import belongs up here with logging. It's stuff I'll probably have all the time. So you get to see the pattern going on. I almost always use logging. I almost always use Pickle, and I almost always use Figlet. So here they are, three of my favorite, always there imports. Now this has to be incorporated where? Here, because if Jupyter Notebook used the pickled arguments from the last time the command line ran, and I'm going to get to the end of that, and that'll be this video. I'm going to clarify completely what we're doing here and why this is both one of the most important and most boring videos you'll ever see. We do intend on running this from the command line with input arguments. at which time it would be a convenient place to pickle the arguments that we're sitting on top of. There's the args value as created by this actual argument parsing process. So let's drop that onto the hard drive, and now that we have that, let's actually go test that. Save, Control-Shift-R for clear all outputs. One more save. I'm still getting the hang of this. nbdev build lib. That's what makes the new version of our .py file, and that should actually be enough. cd into SCOML, one more directory level deep of the same name, very standard convention. You might think there's weird nbdev stuff going on here, but that's the way PyPy development works too. We look here, we see the packages, including the one that was just created, and we know that we can type Python core.py, file name, spam. I guess I don't need the quotes around it. And description, eggs. I'll put quotes around it because we should see it with quotes at some point. Some eggs. Spam and some eggs. Okay, so there's our output of our program. First, our error logging, because it's going through the command line. Error logging is always showing this. It's on purpose. It's to remind me to use logging more often. Whether we're in the Jupyter environment or not, I should make that verbose, saying you are not in the Jupyter environment. And then the object, which is really our args dictionary, even though it's showing it much like a named tuple here. However, we should be able to cd ... Oh, no. It's down in this location. That's an issue. I'm going to have to remember that. This was run from this directory, one level deep. So args.pickle exists with the py files. Vim args.pickle. And you can see when I wrap it that spam and some eggs are in here. It is no longer that original args.pkl that I showed you up here at this directory level. It is now this new one that is inside of it, SCOML, right? So there's another copy of args pickle. So as a little bit of housekeeping, I should jump up to this directory and delete both foo and the args.pickle that is out of location. Now remember that the other one is down there in that subdirectory because that's going to come into play when we do our symmetrical unpickling process. So whereas we're dummying up the args, why dummy it up when you can just do the symmetrical reverse? With open args.pkl. Now instead of as write binary, it's read binary. We need a file name, a file handle on it as well as handle. And with that handle, we can do load, some strange API conventions, dump and load, dumps and loads. We want the singular version because it's a file system operation instead of a string in memory. And it is a file. Now follow this. It is no longer a file called args.pkl. And I'm tempted to use the path lib to do these slashes, but we know that forward slashes work. So we're going to use forward slashes. It works even on Windows, as you'll see here under the Jupyter environment. SCOML. It's loading out of the directory that it knows is in that same location, so we can put an optional // in there. That's the same thing as not putting it. It says, from the directory I'm in, look in the subdirectory called SCOML for this file, and something can be set equal to that. That's being loaded. Pickle load. Let me check my notes before I commit to it. Yep. Yeah, args, it can be Oh, look at that. It can be set right to the handle. Pickle.load handle. The whole kit and caboodle. Oh, I'm putting the file name in there. Bad mistake. After all that talking, it's not args.pkl anymore. Whew. Common mistake, swapping your string location of your file with the handle that you're sitting on that represents it in memory. So, okay, JN is not defined because I restarted everything and I have to tell it whether JN is true or not. One more, you can't find this, SEMO, so it helps when I get the spelling right. For those watching accurately, you must be going, ah. Okay, and then pickle not defined because that import has to occur too. Again, I reset the notebook, and I will run it explicitly here, but I'm going to show you the top-down running and then the final good habits here that should always be done. So it's still showing file name here, description here, because I didn't get rid of this guy here. And I didn't set args equal to it either. And an interesting thing about context management, really in this program, args is appearing for the first time here, indented under an if, indented under a with open, and there's args equal being said for the first time with no instantiation or whatever you want to call it under static languages. And that args is going to be available here for print args. That's the way Python works. It's one of those nuances. So here you go. Description is some eggs, file is spam. It reversed it. Dictionaries don't care about, well, dictionaries do have orders now. You're not it's just not supposed to depend on it. Okay, so this once again is mission accomplished. What we have just done now is added this amazing ability to run our Python program. Now, I guess I do want to, once again, commit it. Not commit it. We're not committing it. I need to generate it. So we do blanking of the notebook before we do an nbdev. Now, I can just go right for build lib. There's other stuff I like to do at that time, like cleaning the notebooks, but I'm not going to do that. So where it was spam and some egg, we can say file name is, you know, something more logical. Like if this is something that's going to be crawling websites, we're going to name the file after, you know, the web name, site name. And the description is going to be, you know, a big job, a big scheduled job. Okay, and then we go back here and we run the thing as if Jupyter, and we'll do top down. Top down for me is Control-Shift-E, restart kernel, and then run all cells is what Control-Shift-E is for me. You might want to do your own key binding, but there you go. It comes out saying description is a big scheduled job, and the file name is site name, which came over from the command line over here. You see? So whenever I run it from the command line now, it pickles into that location the arguments I just used, so that debugging on the Jupyter Notebook side is super duper easy. And we're moving this project ahead with some great rapidity. I'll think about what my next step is, but you can see here how this kind of stuff is both not that much to look at. You know, I can now delete stuff. You don't need to see Figlet showing. This certainly shouldn't be here. The demonstrating of how main works, showing how nonsense works. The creation of the lambda function will create there. The creation of the Figlet, lambda print, fig, the creation of the fig function. We don't need this. And now we are exporting this, but the hello function is just sort of nonsense. So now it's starting to look a little bit more like generic all the time scaffolding. And I'll show you one more thing here, some of the conventions that are being forced to use. Now that I've run this, PEP8 is in memory. That should have inserted a space underneath here. Well, we'll see PEP8 enforce itself over time. There, I inserted a space there, but not there for some reason. I thought there was going to be spaces between your original import definitions and when you start doing other stuff. But Shift-M is for merging cells. Checking whether it's Jupyter is now kind of as fundamental, and setting the is Jupyter is also kind of fundamental. So this is how I instantiate many of my programs now. You can move the assert to the bottom. It's nice to keep a test in there. And we have an import that's occurring here that should go with my global imports. I like to use this getting longer approach. When you see a double cursor, you hit the escape and put your cursor back down. JupyterLab is still working out some user interface bugs. So that looks pretty good, right? This is some magics, and the fact that it is a nbdev thing. Core tells us what .py file is going to be created when nbdev build lib is run. This I need to learn more about, something required for nbdev, so I leave it there. The export statement that says everything in this code block and every other code block that uses this comment will be exported into the file named core. That's good. And then stuff I do every time. Let me just do one more merge, because these two cells are kind of stuff I do every time now too. That's a redundant export, and parser and add arg. Jupyter. So it seems that this parser stuff belongs better. No, it's immediately used underneath. It's in context. This is Jupyter here. Yeah, that's pretty good. It's a little too much vertical scrolling for stuff in common on every project. This is going to be at the top of every project. However, the functionality it fulfills is so important here, and it is so cross-cutting of every kind of piece of work coming like it in the future, which is all my work, basically. No, not all my work, all the technically complex work that give me my secret weapon advantages of this type. So I'm happy there. I'll stay with that. We'll do one more top-down run, Control-Shift-E, to show you it running in the context. Prints the arguments that were last used here. We do a save, and I'm creating my habits. I clear everything, I do a save, and the full habit here, and that's where I'll leave off the video, is an nbdev clean notebooks. So first you clean your notebooks, then you build your lib. Now a git diff should look pretty good. I shouldn't have too much metadata floating around in there. Everything in here should really represent, see, I had metadata. I probably had committed metadata in there before and garbaged up the directory. Keeping these repos really pure and clean is going to be an art form as time goes on. I don't think I'm going to fully accomplish it with this particular project, but being able to follow your git diffs, diff by diff, as the project evolves is one of the points of using nbdev. But it takes a very pedantic approach to be able to keep your git repos really that clean. But I'll be satisfied with where we're at now. Git, first I'll clear, git commit, pickling args. And that's pretty much it. Git push. And that's now up there on GitHub. Really good video. Thanks for joining me. Hope to see you again soon. And don't forget to make your Linux command line commands from within Jupyter Notebook.